Thanks for recording it, and thanks for joining this afternoon's webinar. So I'm Yi Chao, and I'm from I-VTech Solutions. So together with Tech Data and Autodesk, and our guest speaker, which we'll introduce shortly, we hereby jointly present today's webinar on manufacturing solutions on Autodesk. So next slide, please. So I-VTech. So a little bit more introduction on us. So we are I-VTech Solutions and authorized Autodesk reseller partner specializing in product design and manufacturing. And we have over 20 years in providing computer-aided technology solutions, similar to what Autodesk offers, like 2D, 3D, CAD modeling, analysis, simulations, and all the relevant related end-to-end solutions and services, which we will go and talk about. The next slide, please. So a little more on what we offer. So we provide end-to-end solutions based on our customers' needs and goals. So we break down our solution down to these three pillars: design, use, and make. So some of the solutions we provide are under design. We have modeling and drafting.
Echo.
Sorry, my mic has some issues. Okay, so for under design, we have 3D modeling and drafting. And for simulation and the analysis field, we specialize especially more in the simulation for plastic injection molding, and then computational fluid dynamics, CFD, and FEA simulation. And we do consultation services, and we can generate reports and consult based on your requirements in this respective section. So on the under make, we provide CNC post-processing, and very popular these days, we offer 3D printing and additive manufacturing printing services. So lastly, under application, we cover both software and hardware implementation, and we can do training of software and systems, and even customize the training for your unique requirements, and also product data management solutions. So on the next slide, just a little overview on the industry partners and clients that we serve. So, over the years, our clientele have expanded, and we have from a wide variety of industries and segments. So we have government agencies, universities, Institute of Higher Learnings, research institutes, oil and gas, in semiconductor, electronics, tool and injection molding makers, interior fit out, and consumer products. The next one to show the other customers that we have. Yeah. And so we have been serving them and offering value-driven solutions. So yep, this is our contact from our company website for more on what the service we do, and our sales personnel's email. I'll paste them in the chat link later. So I'll hand over to our guest speaker today, Syed.
Hello, good afternoon, good evening, everyone. Okay, so my name is Syed. So I'm just doing a bit of a sound check. Can you guys hear me? You can type it at the chat box if you can hear me clearly, or it's very soft, or my voice is not clear. Okay, so let's see. Clear. Okay, all right. Thank you for responding. So my name is Syed. So I'm the solution consultant, or so-called a technical engineer for Tech Solutions, which is Autodesk distributor. Okay, so for today's session, we're just going to talk about transitioning from design to manufacturing. So seamless transition from design to manufacturing from within Autodesk ecosystem. So okay. So design and manufacturing industry is very so-called defined by many vendors that have created categories such as CAD, CAE, or CAM, okay, and that are focused on task-based application. Over time, this process has introduced so-called three sources of friction. The first one is data. So in traditional product development process, right, it creates and consume a huge amount of data, okay, often in different formats. So probably if you have multiple departments or maybe multiple office, probably they're using different software or maybe different version of software. Sometimes they do not work together real well, and sometimes they have some issue with the translations, or maybe you are transferring data and so on. Okay, so the second so-called sources of friction is so-called under experience, which is single user may have multiple, a single user or single engineer probably have multiple of tools for them to use, right? So maybe you have one tools for design, one tools for so-called, and another tools for CAM, another one is probably some other tools for collaboration and so on. So there are probably a lot of tools and requires an experienced person. So in case you are getting in a new person and then training them to get used to all that tools, it could probably took some time, some learning curve and so on. So in terms of technology, in order to take a design through manufacturing, right? So you probably need many tools from different vendors to complete this process. If you receive files from external parties, you need to so-called process the files first, give it the so-called process that you want to use, whether you want to face it, cut it, and so on. Okay, so you basically have to be a PhD or a master or efficient in the product development process to stitch these so-called documented tools together efficiently. So this is where, if you are working with multiple of tools, multiple of solutions. Okay, so so we believe everyone involved in the design and manufacturing process should have access to the data in a connected and seamless way. So it combines design, documentation, rendering, simulation, and even for today's focus, it will be CAM, around a common user experience and data model. So basically everyone will have access to the data, so everyone is working on the same data. So in other words, we making it integrated, so everyone have the same data and same tools. Okay, so we're bringing together all these technologies that previously been separate. So inside our product design and product design PDMC, okay, product design and manufacturing collections. So we have all these tools together inside one package, which is very, very helpful, very, very useful for all the users, because all the so-called solution will work integrated within Inventor. Okay, so basically it's just as simple as changing a tab inside the applications. No longer need to open separate applications. Okay, so manufacturing has changed. So so you should take a look at your tools, whether it's currently up to date with the current trend, current industry trends, and current industry focus. Okay, so traditional CAD, okay, platforms are always fragmented, disconnected, and often cause costly inefficiencies, and also many other challenges along the way. Okay, so all this separate software breakdowns communication, and whenever changes are made, there probably some, when let's say you need to make some changes to the components, right? So if everything is disconnected, you need to make multiple changes, probably to the drawings, to the parts, to the assembly, to the bombs, and so on. So it will take longer time. So imagine that everything is integrated. You make one changes and it updates everywhere. So this is very, very helpful. Okay, so go from design to machining faster. Okay, because changes update associatively. So there's no longer need to do any file conversions, since everything is working in the same platform. So when you make changes, it will update everywhere. Okay, collaborative. So you can easily, CAM programmers can collaborate with designers, engineer, and machine operator for faster decisions. Okay, so apart from making designs or making CAM process, so you can collaborate. So you can document all the comments given, so you'll know that what has been so-called what is the new amendment or what changes need to be made. Okay. Okay, accessible. So So PDMC is so-called can be very useful from design to managing, and when we talk about manufacturing, right? So when we talk about CAM, whenever we want to create a post process, so Autodesk has its own post processor. You have to create G codes. Okay, so all this is available on the Autodesk website. But of course, you can always help to create custom posts, or if you have your own posts, you can also modify your own posts, or from the existing posts in the website, you can look at it if it can be reused, and so on. Okay, let me just, okay, here is all the application within product design and manufacturing collection. So so everything, most of the applications here works on top or works together with Inventor Professional. So Inventor Professional is our hero product, which we create the design, assembly, drawing. Okay, Inventor Nastrans is we create design validations. Inventor CAM, where we create our post process, we create our G codes, tolerance analysis to check every form, fit, and function of components. AutoCAD. Okay, you should know AutoCAD 2D pioneers. Okay, Inventor nesting. So in case we are creating, you need to create nesting before your laser cut process. So you can do it inside PDMC. You do not need to have any other application. So factory design utilities for factory layout plannings, bulk basic for simple data management. So inside the collections, Fusion 360. To simply put, I can say that Fusion 360 is almost similar to what I have explained above, but it's on the cloud. Okay, with a bit more features. Navisworks Manage, in case you want or you need to collaborate between multiple file formats. Okay, to create clash detection between few so-called factories or few machines or few assemblies, you can do it inside Navisworks Manage. Recap Pro, in case you are working with point cloud data. Okay, so you can process it with Recap Pro. 3ds Max will help you to create photorealistic rendering animations. Okay, that's all on the product design manufacturing collection. Here is basically they are the same. Okay, this is the new so-called icon of PDMC. Okay, so now let's look at Inventor CAM or Fusion CAM. Since our topic today is about CAM, right, to manufacturing. Okay, so Inventor CAM or Fusion CAM. So from the product list earlier, so we saw we have Inventor CAM, we have Fusion CAM, we have Fusion 360. Fusion CAM is basically inside Fusion 360. Okay, so basically they are integrated CAM for a seamless workflow. So we can, to simply put, you can do milling, turning, lathe milling with 2.5 to 5 axis. Okay, adaptive clearing technology to reduce roughing times and also to extend your tool bit life. Okay, basically it's a strategy, it's a cutting strategy. Okay, so just to show a little bit on the layout. So basically, this is how it looks like from within Fusion CAM interface. So we can see on data panel have all the parts. Okay, workspace switcher to change from design to manufacturing. Okay, we have all the toolbars, all the browsers, all the timeline here. Or let me go to our Inventor CAM layout. So basically, this is Inventor interface, but you'll see that we have a lot of tabs here. So basically, from within Inventor, we just change to CAM tab without even need to open up a new application. It's basically inside Inventor. So you can see from within that tab, we have all the manufacturing related features. We can create milling, we can create turning, and we can even specify or custom made or key in our own input for all the tool bits and also the holders and also the cutting rate and feed rate. Okay. Okay, so just to highlight, so how does it process? How does Inventor and also Fusion process? It's basically almost similar. So whenever we create setup, right? So basically it group them as a setup. So let's say setup one, this is all the so-called process that's been created within setup. Okay, so let's say I create adaptive layering, creating pockets and so on. and then probably let's say I want to create, or I want to machine at the back face, okay, at the bottom face of the components. I need to logically I need to turn it back, and then I need to create another setup. So there will be setup 2. Okay, if there's another setup on the side, so you need to create setup 3 and so on. So basically that's the concept of it. Okay, a little bit more details on the capabilities of Fusion CAM and Inventor CAM. So 2.5D milling, 3D milling, probing, dex milling, multi-axis milling, 4-axis plasma, and also turning. Okay, let's look at some adaptive clearing technology. So here is, let's see, when we do in Fusion CAM and also in Inventor CAM, so with adaptive clearing, we can constantly remove material in the same rate, shorter mill runtime. So basically, it's faster. It also extends the tool life and also can run maximum fit throughout cuts. So if you can see from the image, right, from on the left-hand side, so traditional cuts will load. You can see separate face to the tools bit. So basically, the pressure or the tool is not evenly used. Okay, some is not used more, some is not. Okay, but with so-called adaptive clearing, we can set it to high efficiency roughing with constant chip load. Basically, the tool bit will be used evenly. Okay, let's look at a bit of some details. So from traditional pocket, it moves like that. So it moves a little bit, but for adaptive pockets, so it moves something like this. So you can see the differences. You can see from the color of the image on the left-hand side, the tool area used is only at the bottom. Okay, put a lot of pressure at the bottom, but when we use adaptive pocket, we actually try to so-called make sure that we use more of the tool on the tool faces. Okay, so evenly used. So whenever in reality, right, so whenever we machine, right, most of the time with traditional methods, right, okay, traditional pocket, often our tool bits will have issues here. Okay, we'll start gouge and so on because of this area is broken and so on. So whenever we use adaptive pocket strategies, so it lasts longer. Okay, the tool is used more evenly. Okay, so just a little bit image on the things, the pockets, additive, to the additive, contour, trace, engrave, slots. Okay, drilling, of course, can do drilling, thread and bore, circular. Okay, when we look at 3D strategy or 3D toolpath, basically something that even more complicated, a bit more complicated than the previous one. So we can do parallel, we can do morph, contour, scallop, radius, spiral, horizontal, and so project. So this is the image you can see. So a little bit different than the 2D strategies. Okay, it's been separated into categories inside CAM interface. Okay, here is just a quick video on how it looks like. So in case you want to apply pocket here, so you're selecting area. Basically, we just select the face of the 3D models, where to cut until where, specify origins. So basically, the Inventor CAM or the CAM solution is smart enough to detect where to cut. Okay, since you are the creator, or probably you know the product, the 3D models well, right? So you know where to cut until where, what's the material to use, and so on. Okay. So why integrated CAM is so different? So basically, in normal day-to-day tasks, so without integrated CAM, so basically, so whenever engineer order a products or asking for a product to machine, so you need to import the geometry, make sure the sizes are correct. Okay, change in schedule, make changes to the tools. Okay, make sure the holders is in place, or the holders is available. Okay, adjust the speed and fits of the machine, adjust mating components to fit. Okay, and use. But within our PDMC workflow, so basically this has been that previous workflow has been simplified. Okay, so basically we create, open our CAD data, define job setup, define operations, simulate our toolpath, and create our NC code. Okay, so just now we open up the CAD data, so and then we define the job setup. So like I showed earlier, so we choose what the process that we want to use. Is it milling? Is it probing, or so on? So we just basically specify the process, define the job. Okay, define the operation, whether we want to use facing, roughing, finishing, drilling, okay, chamfering, okay, simulate toolpath. So we, whenever we already process the things, right, we can simulate to see whether what we are doing here is correct or not. Is it logically processed? Okay, if there's any clashes, will there be any gauge? Will there be any errors? So it will be shown in the simulation here, you can see. Okay, and then after that, basically we just create some NC code. So basically we process it using the selected post that from the website, or maybe you have your own custom post, you can use it also. Okay, so a little bit of a short demo from Inventor Professional to Inventor CAM. This is just to give you a bit of so now let's see how do we so-called transition from the modeling, 3D modeling, or the design data to CAM. So basically, let's say if you have PDMC, right, product design and manufacturing collections, it means that you have the access to download and install Inventor CAM. Okay, so it's a separate install from Inventor, but it actually works on top of Inventor. So basically, you can access this Inventor CAM features from within your Inventor Professionals. So it's pretty simple. So whenever you open up your parts or your components or your models, you will see a CAM tab. Okay, so now you can see that this is the so-called Autodesk Inventor interface, which I believe should be familiar to everyone. Okay, so this is all the 3D modeling where you give features to create 3D stuff, right? Extrude, revolve, and so on. But whenever we want to use CAM, so we need to go to CAM tab, and then you can see the ribbon here all change to CAM related features. We can see from toolpath, job, milling, 2D milling, 3D milling, multi-axis, turning, cutting, and so on. Okay, so that's how you change from your 3D design to CAM from within Inventor. Okay, so from here, how to move on from here? Basically, from here, you need to start to create a setup for your programming. Basically, choose the type of the material, choose the type of machines, the operations to use, specify the model orientations. Okay, specify the models, and specify the stock size. Okay, what stock size or stock shape you want to use, and so on. All right, so this is just a big intro on the interface. So how it looks like, how do we change from design to manufacturing straight away from Inventor. So let me check chat box if I have any questions. See, no, chats, no, Q&A, no. Okay, so I'll proceed. So this is from within Inventor. So next at okay, so from here, so let's say I want to create or want to choose the tools to use. So I can choose it from the tools libraries. So choose the type of tools I want to use. I can change the diameter, but of course, all these details come from the catalogs of your tools. Okay, so and then we need to specify the coordinates. Okay, the origin of the parts. Okay, origin of the raw material. So the site offset. Okay, the offset of the machine. This need to be tallied with your machines. Okay. So again, we need to specify the clearance height, the passes. Okay, so this is just on facing. So just within a few clicks, we already got the facing process done. And then next, let's say I want to create some adaptive clearing. So I select the area. Okay, in this case, I'm selecting the edge and also the face here. Okay, I can specify the so-called edge, the outer boundaries. Okay, specify the clearance. Okay, so let's say after the tools, we track from the raw material, the height, okay, the multiple depth, the roughing step down, we can specify. Also this is also depends on your machines. Okay, you can specify, you can customize all these details. Okay, so let's just simulate the things and see how it looks like. So this is just two basic, simple process. So let's say we can check other things. So first thing is facing, and then adaptive clearing. So how we do this, just earlier on you see that by just selecting edges, faces, everything is from the 3D models. So there's not really any calculation made manually from area to area, point to point, and so on. Basically, just by selecting the edges and the face of the 3D models. Okay, so let's say in this case, I have one revolutions that I want to make. I want to use it as so-called my cutting boundary. So we can use that. Okay, so I can choose the surfaces that were created in the design stage, right? So, okay, can specify the selection boundaries, okay, the edge, okay, and also cut it until where. So basically, bottom reference, we specified the bottom reference, or we can choose also the stop reference, which is the raw material, bottom or top. Okay, so you can see it's processing. So you can see it basically processing. You can see the blue lines there. It's processing nicely. So let's just simulate it and see it. So we can see it visually. So we can see it better. So how do we cut? Okay. So we can see it like that. Okay. So basically in this stage is still just doing roughing, or removing a big chunk of material out. Not yet we do any so-called finishing setup. Okay, so and then let's say after we do some roughing, we need to do some finishing, right? So we can change tools, change the proper tools to use. Okay, we can choose the same process. Basically, select the surface or the boundary that we want to use. Okay. Specify the height of where to cut, okay, from where to where. Okay, and then on the passes tab, we specify on the passes details, okay, like step down, area detections, shallow step down. Okay, so it's processing. So you can see it's a little bit more detailed. You can see from the lines itself. Okay, so let's just see the simulations and look at the roughing. This is roughing. You can see at the bottom there the timeline. So it will separate by so-called process. So now it's doing the contour. So you can see from this view, it's doing contour to do some finishing work. Okay, so let's say we go to the finish one. So let's say, so from here, you can simulate the thing, so make it faster. Okay, so this is, I open up the completed one, so you can see the whole process straight away from here. Okay, just to give you an idea, process by process, okay, the workflow from one process to another. Okay, so let's say from here, we can see that we can move the contour to the back. Okay, so we can see the machining time, okay, the operation use, the tool changes. Okay, so all this detail is given, so we can create even a setup sheet. Okay, setup sheet, like the information needed for the operations. So what tools to be used, okay, the details of tools, how long it will use. So everything is inside that setup sheet. So now to process, so we need to choose our post processor. So we can choose from this is from the existing libraries. So in Autodesk libraries. So from there we just process it to our NC codes. Okay, so we can check the post library. So you can choose. So in this case, we are using milling, so you can filter it by milling to see. So this is the default post processor available for user to download and use. Okay, so there's a lot in here, and it keeps on updating every day. So whenever there's new one, it will update. So it's very easy for user to download and also load it to their Inventor CAM or Fusion CAM, so they can use it directly. Okay. So again, for standalone CAM, right? So we create data, export data, import, export data from, let's say, one applications to, and then on the other application, we import the CAD data, we define the job setup, define operation, toolpath, verify toolpath, and create codes. In case there's changes to the components, okay, in case, let's say, holes need to be bigger, or probably you need to add some chamfer or fillet to the component. So you need to update the CAD data again and repeat the same process: export, import, redefine job setup, basically redoing everything. So if everything is done within PDMC or with our integrated CAM, so you can actually cut half of the process. So when we create the CAD data, we can define the job setup, define operation, same thing, verify toolpath, post the code. If there's any changes, we just update the files, regenerate the toolpath. Okay, basically it's like refresh, so we just regenerate the toolpath, verify toolpath, and also post the code again. Okay, benefit of integrated CAM: streamline workflow, simplified data structure, because you are using the same inventor to create your design. So basically it's a very, very similar interface, even to your AutoCAD, shorter learning curve, full CAD functions. So, and also any CAD within Autodesk Inventor, basically we can open up all the formats from other applications. Okay, so that's on CAM. So let me see if we have question before I go for nesting. Any questions? So I don't see any on the chat box. So let me just go to nesting then. So within PDMC, so we have nesting capabilities. So basically to help to optimize manufacturing strategy for sheet metal cutting. Okay, I'll add a little bit here. It's not just for sheet metal, but also for other components that needs cutting as well. Okay, so basically the idea here is just to reduce material waste. Okay. So the workflow is pretty much similar to the CAM workflow. So we have models, we create nests, and we cut. Okay, so within nesting, so we can, it's basically embedded into Inventor as well. Okay, so we can generate cutting path with Inventor CAM. So we can review and compare the reports. So you can see image here, right? So the things with purple and green color. So this is the nesting report. So you can see how the components is being sorted into the raw material. The dotted line is the raw material. So it's been sorted out nicely within that raw material area, so that we will reduce the material waste. Okay, so let's see from this video here. So from here, so let's say from an assembly, I can straight away create a nesting straight away from assembly. Okay. Selecting all the components, so it will load automatically into nesting. As you can see, this is within Inventor interface. So you can see different components have different thickness and probably different material as well. So it's been sorted out. So all the same material is and same thickness will be sorted out together. Okay, so like this thing is the same material and same thickness, so it will be placed under one same raw material. So we can specify our raw material size. You can see now is 610, maybe too big. Okay, make it smaller. So and then we can change the setting, whether we want to allow any mirroring, flipping, or any rotations to the profile. So you can see from previously, just now we so-called create the nesting, it will automatically place. So we already got the nesting report. So now what happened is, I want to make changes to the components. So in this case here, I remove holes from this part, okay, and from this part as well. So let's just remove the holes, okay, and go back to nesting. Okay, save it, of course, and go back to nesting. Basically, I just recalculate it. So it will auto recalculate the nesting operation just now. We don't have to redo. Basically, it's just update itself. And then we can send it out to CAM to create our so-called laser cut operations. Okay, so from there, it can be export out as DXF as well, or we can straight away generate a CAM process from within Inventor. So in this case, I want to use laser cut. Okay, so it will help. So it will generate straight away from Inventor. Just it's very straightforward. Okay, very easy. Everything is integrated within one solutions. Okay, so let's talk about next generative design. So it's basically generative design is a design exploration technology which we want to get more options. So basically, cloud will have to generate simultaneously generate a CAD-ready solution based on all our rules that we put in. So based on our or based on the real life condition of the components. So basically, we put in all the so-called constraints, all the force, and all the materials that we want to use. And generative design is smart enough to give us all the options to choose from. Okay, so how does generative design help the product development process? Okay, so basically from generative design, so we create multiple manufacturable options, okay, that can, okay, basically we create all these options that are ready to be manufactured, okay, and choose design to production and produce. So let's say if we do not use generative design, basically manually we create design, okay, and then from iteration phase we send to productions, and then production send it back to us engineers. So this cannot be manufactured, too expensive or too hard. So please redo your design. So it will go back. Okay. So whenever we create or we use generative design, so all that criteria has been taken care in the iteration phase. So we don't have to worry about the so-called this area design to production. So because we already make sure that everything can be manufactured, because we set the rules on how to manufacture. Okay, here is just one good example. So let's say in this case, I want to so-called create generative design for this swing arm. So basically the green one is the area I want to preserve. Okay, the red one is so-called like an obstacles that want to avoid. Okay, we don't want to clash with that. And we can choose our method of manufacturing, additive, casting, milling, hybrids. Okay, and then from there we can just create 100, if not thousands of ready-to-use options, okay, to choose from. So from there we can filter it out based on the graph. So we can choose maybe top 5, top 10s. Okay, so you can see this is something you can see the strength, okay, the mass, manufacture time. You can even add more criteria, maybe like price and so on. So this case we do additive manufacturing and also hybrid, right? So if you just set it to milling, so it will give you a milling ready result. Okay, so any question from the floor? Any questions? So I'm at the Q&A section. Basically, I am done with the presentations. Any questions?
If you have any questions, feel free. You can type in the chat box, and then together with our solution experts here, we can address them. If any, I think we hold on for 1 or 2 minutes.
Okay. So I'll wait on the line. So in case you have questions, you can type it at the chat box or the Q&A box. If you don't have any question now, you can also send an email
Over to us, to I-VTech, we will address accordingly. Copied our contact on the chat box, so you could save it. And this is the link to our company site. Please also note, we will send a copy of the recorded webinar to other attendees here, so you could always reference this in the future.
I think there's no questions.
Yeah, I think we can call it a day. So do keep look out in your email and our company LinkedIn for upcoming webinars, so we know about the next 1 or 2 months. So we'll be still be holding a series on knowledge sharing info on Autodesk and the solution. So yep, thank you. Okay, thanks a lot, Syed.